my name is Ivette Mosso and I will be describing action potential in a neuron cell. Action potential occurs in excitable cells such as neurons. An action potential will occur when such a cell is stimulated and then needs to send a signal down the axon. This process will occur in the nodes of Ranvier. Over here we have the sodium ions in purple, which are mostly concentrated in the extracellular space or the outside of the cell. Then we have our potassium ions, which are concentrated in the intracellular space or the inside. The yellow part signifies the semi-permeable membrane of the cell. The ions will try to balance out by diffusing through the membrane, but since it is semi-permeable, only certain ions will get through. The purple channel is the voltage-gated sodium ion channel. The yellow channel is the voltage-gated potassium ion channel. The first step is the resting state. During this state, the neuron can be said to be at rest because the signal stimulus has not been felt. In the resting phase, the inside is more negative than the outside. Both these channels will be closed during this phase because no stimulus has arrived. As you can see, both channels are closed. They are then called inactivation gates. Action potential will be initiated only if a stimulus surpasses a certain threshold. The first threshold it must surpass is the resting threshold of 70 millivolts. The second phase is the depolarization stage, or the rising phase. Here the sodium gates will open and the sodium ions will rush in. The process of sodium ions rushing in is called an influx. Since the potassium channels will not open, the inside will become more positive because of the concentration of sodium ions, called an overshoot, which then will raise the millivolt to the maximum threshold of negative 50 millivolts. An action potential will then be triggered. After this, the potassium channels will open and the sodium channels will close. The potassium will then leave the inside of the cell into the outside. The rushing of potassium ions into the outside of the cell is called an efflux. If too much potassium leaves the cell than normal, it is called hyperpolarization. The last stage is the recovery phase or refractory period. Both channels will close, but the sodium-potassium pump will be activated. This pump, the sodium-potassium pump, will use energy to move three sodiums out of the cell and 2 potassiums into the inside until the cell returns to its normal.